The Gravity Assist podcast is hosted by NASA's Director of Planetary Science, Jim Green, who each week talks to some of the greatest planetary scientists on the planet, giving a guided tour through the solar system and beyond in the process. This week, he spoke to Tom Wagner of NASA's Earth Science Division, to discuss NASA's work studying our planet. In this first part of their discussion, the pair talk about Arctic sea ice, disaster response, and how what we learn about Earth can be applied to other planets and vice versa. Here's a condensed version of the podcast. You can listen to the podcast here, or read the first part of the transcript below. The Earth, as seen on the 15th of October 2015 by NASA's Earth Polychromatic Imaging Camera EPIC on the NASA NOAA Deep Space Climate Observatory DSCOVR. Image credit NASA GSFC. Jim Green: I think many people don't realize that NASA really is not only exploring space beyond Earth, but we're studying Earth as a planet in its own right, and we're doing that because it allows us to make life better here on Earth. So, Tom, tell me much more about what Earth science is all about here at NASA. Tom Wagner: the biggest thing with Earth science at NASA is that we're trying to understand how the Earth works as a big system, that is, how all the parts knit together. To do that, we need things like satellites and aircraft that can cover the vast distances across the planet so that you can see how change in one place is connected to change someplace else. Jim Green: the Earth has done nothing but change over time. From a planetary scientist's perspective, these changes take place over billions of years. That's how we look at it sometimes, but in reality, NASA's looked at Earth from space and seen changes even over the last 50 or 60 years. What are some of those changes that we see? Tom Wagner: one of the biggest places, and actually some of the first satellite data that was collected about the Earth was of the Arctic sea ice, where they used rockets to take pictures of it back in the 1960s. What we've seen is that, over the past 30, 40 years, we've lost something like 80% of the ice that used to be there by volume, and it's an amazing change. It's like turning one of the big knobs that controls the Earth as a machine. Jim Green: that water's got to go somewhere. What are some of the missions that look at that, and what are they telling us about where that water goes? Tom Wagner: there's a bunch of different things that we do. One of them is that we use satellite radars to look at how fast the ice on the land, like in Greenland and the Alaskan glaciers, is flowing into the ocean. We use satellites like GRACE Gravity Recovery and Climate Experiment, which measure variations in mass at the Earth's surface. Then we have satellites like IceSat Ice, Cloud and Land Elevation Satellite, and IceSat-2, which we're going to launch in 2018, which look at the height of the ice and how it's changing. An artist's impression of the IceSat-2 satellite. Image orbital sciences. Jim Green: how does NASA study and provide information about earthquakes and hurricanes, floods and wild? Tom Wagner: one of the important things NASA does is to try and develop the next generation of tools for better forecasting of those events, so we can do a better job figuring out what the impacts are, and the kinds of work take all different kinds of approaches. With hurricanes, we'll look at those with satellites. We'll also fly over them with aircraft that map the structure of the hurricane so that we can figure out its power and the direction we're going. We work closely with the NOAA National Oceanic and Atmospheric Administration on that. When there's something like a terrible oil spill in the ocean, we have special radars that we'll put out on planes to go out and map the extent of the spill, because that's really hard to do. When it comes to things like earthquakes, we use satellites to map the motions of the tectonic plates so that we can get a better understanding of how the Earth moves and where earthquakes might happen next. We even have a program that specifically looks at natural disasters and how we can best support the other agencies that are delivering the aid. Jim Green: one of the things that NASA does that really is so important is to use those assets to provide quick response capability, and to distribute that data to the right places. How do we do that? Tom Wagner: when there's an action like that, the messages come into NASA headquarters to the person who is the disasters program manager. Right away they rally the scientific community, including people from the NASA centers but also from academia, to figure out what are the best things we can do to help. One really good example was the Nepal earthquake that happened in 2016, where they got together to look at things like landslides, because it's not just what happened during the initial shaking, but later on when you get rain, how has the landscape changed and where are there most likely to be landslides. Responding to the devastating magnitude 7.8 earthquake in Nepal in 2015, this 40 by 50 kilometer 25 by 31 mile damage proxy map shows the region around Kathmandu. Using radar data from the Italian Cosmos-schemed satellite, the colored pixels on the map indicate where damage caused by the earthquake is, by comparing two old satellite images. Image credit NASA JPL Caltech Asia Google Earth. Jim Green, your area of expertise is in the cryosphere. What does that mean? And what do you do exactly? Tom Wagner: yeah, it's kind of a fun job title. Technically, I'm in charge of all the ice on the planet. I work pretty closely with colleagues at other agencies like the NSF National Science Foundation. We're trying to understand how the Earth is changing as a system, and one of the biggest things is how are we losing ice from places like Greenland and Antarctica, and how is that contributing to sea level rise, and then also how is the sea ice changing in the Arctic and Antarctica, and what does that mean for us as a planet? Then we're also doing things like looking at ice and snow in the Himalayas to understand how water resources are going to be affected for the billions of people who live here as the planet continues to change. Jim Green: one of the things that we've uncovered is that, in Earth's past, our planet has gone through various stages, one of which we call Snowball Earth. What can you tell us about what happened during that period? Tom Wagner: you're talking about going back hundreds of millions of years to when the planet was frozen solid from the poles to the equator. Probably what happened was that it was a time when carbon dioxide (CO2) was drawn down so low from the atmosphere that the planet got cold. Now the big thing is, once you freeze the planet over, and we have good evidence of that from things like glacial striations that we find on rocks from those periods, how do you get the planet out of it? Because ice reflects almost all of the sunlight that hits it back into space. It's like a perfect mirror. One of the theories is that eventually volcanoes generate enough CO2 to begin to warm the planet up, so that that ice actually melts. It's a good example of how we can apply the same principles we see operating on the Earth today to what happened back in time, to understand how the planet changed and evolved. An artist's impression of Snowball Earth. Image credit MIT. Jim Green: the Snowball Earth era reminds me of several objects in the solar system now that we're trying to study, one of which is Europa, which has got this fabulous icy crust over the whole moon and underneath it perhaps as much as twice the volume of water than exists here on Earth. So, the study of ancient Earth during these phases might actually inform us as to what's happening on some of these other planets and moons. Tom Wagner: yeah, and another thing is the techniques that we develop to study ice here on Earth also apply to Europa, like the scientists that work on radars that will go to Europa to map the structure of that ice. They're some of the same scientists that work in Antarctica today to help us map the ice and the bed underneath the ice. Some of the theories we've developed for how the ice changes, how it carves, how it breaks, they also apply on Europa. It's colder and it's a little bit different, but it's the same basic principles. What I think is some of the most exciting research going on today is where people are drilling through the Antarctic ice to tap the watery bodies that are underneath them. Some of those are locked on land, and they're not in connection with the ocean, and they've been separated from the atmosphere for many millions of years, and so, even astrobiologists and a Originoflife crowd are interested in those. You have places like the Ross Ice Shelf, which is the size of France, where the massive glaciers of Antarctica flow into the ocean and flow. I know the planetary science community is joining with the earth science community to make a probe that will go down through many hundreds of feet of ice to the ocean and sample it and then come back to the surface. That's exciting for planetary science as a prototype, but it's also exciting for earth science because no one's been there before, we have almost no exploration of it, and I think it's a really good joint effort. Tom Wagner of NASA's Earth Science Division. Image NASA GSFC. Jim Green: Antarctica is such a special place. You've been down there many times, so what is it like? Tom Wagner: for about 5 years I was the program director for Earth Sciences, and what was neat about that job was, if something didn't fit in with another program, it was definitely Earth Sciences. We got to cover everything from ancient dinosaurs to modern mummified seals to earthquakes, which Antarctica has plenty of, and volcanoes and magma and all kinds of fun stuff. So going there was great. It's like going to the land of the unicorns, right? Hardly anybody gets to go there, and the things that you see, do you know, you're touching ice that is thousands of years old, like from the times of the pyramids. The life there was amazing. There are benthic environments, regions at the lowest level of a body of liquid water that are dominated by soft-bodied creatures that are then eaten by seals, and you have penguins hopping around, which are amazing things. One time, I landed in a helicopter, and a whole troop of emperor penguins started sliding and walking towards me, and they surrounded the helicopter, and we had to wait until they got bored and left. Jim Green: so, they were just exploring, too. Tom Wagner, they really like people, it's funny. Jim Green, what have you learned as an earth scientist that would surprise most people? Tom Wagner, I think the number one thing for me is that I think people view the Earth as this incredibly huge thing, and they don't understand that we as people really have the power to fundamentally reshape it, and we've really affected the Earth as an environment, everything from changing the landscape and changing the ecosystems through to changing the composition of our atmosphere and changing the temperature of our planet, and I think that profound shift is one of the most important things that we've learned through our study of the Earth in the last 100 years. You can find part 2 of the discussion here, link available tomorrow.